So what is a mirror? It is a polished surface and it is the reflecting surface we can say. So what is mirror? A mirror is the highly polished surface. It is used to reflect light falling on it. Now we are going to discuss image formation by plane mirror. Just observe here, this girl is looking into the plane mirror and she is observing her image, right? Theta means angle between the mirror. So it's theta, that is 90 degree. Now the number of images will be formed will be 3. Okay, how? Let's look at the diagram. Just observe, this is the point object. Hello students. So today in this class we are going to discuss about the plane mirror in very detail. Basically what we are going to discuss? We are going to discuss about the image formation by plane mirror. So let's start students. We know that plane mirror is a reflecting surface, okay? It's very smooth and shiny surface which is used for reflection of light, and due to the reflection image is formed. Just observe, and here you will find that some examples where you will find image formation by the plane mirror. Just look at the first image. This is the image of monkey. The second one is image of hand. The third one is image of pot, and fourth one image of the birds. You can clearly see here that all the objects are seeing and observing the image, right? And image is exactly same copy as the object. Okay students, so we can say that we use plane mirror as looking glasses. Let's move further. First of all, we have a question here. What is a mirror, students? Okay, so what is a mirror? It is a polished surface and it is the reflecting surface we can say. So what is mirror? A mirror is the highly polished surface. It is used to reflect light falling on it. Okay, so what is mirror? It is highly polished surface. Just like here, you can clearly see here how you can form the plane mirror. So just look at this. You will find that there is a thin sheet of glass, and by polishing one surface of the glass sheet we can form a plane mirror. Just look at this, our plane mirror is ready, okay, and we can clearly observe image ourselves. Okay, so definitely this is a mirror. So how you can form your own mirror? You can cut a thin sheet of glass, and by polishing silver oxide on the one surface you will find your mirror is ready. Let's move further students. Now we are going to discuss image formation by plane mirror. Just observe here, this girl is looking into the plane mirror and she is observing her image, right? So image is exactly same copy as the object, right? So now we will discuss how the image formed, and we will also discuss about the ray diagrams. So first of all, we have to understand how the image is formed, students. So how image is formed? Due to the reflection. When light rays strike the plane mirror, after striking the light rays, they will reflect definitely. Now, at a single point, we will find that the reflected light rays are appear to meet, and they are exactly meeting at a point. So, the point at which the reflected light rays are meeting actually or appear to meet, it's called a image. Okay, so let's observe here. We have taken a plane mirror. Now we will take a point object. Basically, there are two types of objects, students. One is point object and another one is extended object. A point object is very small object, I can say, whose dimensions are negligible, and it is denoted with the point. Okay, and an extended object is the object whose dimensions are quite large. An extended object is denoted with the arrow sign. So let's take first one, point object. This is the point object which is denoted with O. Okay, O means object. Now what we will do? We know that light rays will come from the object, definitely. Okay, so we required minimum 2 light rays. So let's incident 2 light rays here. These 2 light rays are coming on the mirror. These are the incident rays. Okay, these are the incident ray. After reflection, we will get reflected light rays. So these two are the reflected rays. Okay, how we will get these two reflected rays? We will draw the normal here. This is normal and this is also normal. Okay, now we will find angle I and angle R. So this is angle I and this is angle R. Angle I should be equal to angle R from the law of reflection. Similarly here I can say it's I dash or R dash. So I dash will be equal to r dash, right, from the law of refraction. So students, we know that these reflected rays are diverging. These reflected rays are diverging. They cannot meet in reality. But if we will extend these reflected rays behind the mirror, we will find that the reflected rays are appear to meet at a single point. Okay, it's appear to meet. These reflected rays are not meeting in real, but these are appear to meet if we will consider these reflected light rays are coming in a straight line. Definitely light rays always travels in the straight line. So definitely if we will extend this reflected ray and this reflected ray, we will find these reflected rays are appear to meet at this point. And this point is showing you image. Okay. Now we can write the property of image formed by the plane mirror. Just observe the distance of object from the mirror and of image from the mirror. You will find that if object is at a distance x from the mirror, image is also at a distance x from mirror. That means if in front of a plane mirror you are standing at 2 meter distance, definitely your image will be also at a distance of 2 meter from the plane mirror. Okay. Now you will find image is exactly same size as the object. So I can say same size as the object. This is the property. And you will find the image is not real, it's virtual. Why? Because reflected light rays are appear to meet students. Definitely. So here we will say it's virtual and erect. Erect means upright. Okay. And you will also find that the image is laterally inverted. Laterally inverted means if you will raise your right hand in front of a plane mirror, it will appear left hand of the image. And if you will raise your left hand in front of a plane mirror, so it will appear right hand of the image. Okay students, so we can say it is called left right inversion or laterally inversion, right? That means let's suppose this is the plane mirror. Alright. Now if I will draw E letter, so how it will look into the plane mirror? Its image will be like this. This is called lateral inversion. Moving further, now we will form the image of an extended object. An extended object is denoted with the arrow. Now let's mark 2 points here, A and B. Okay. We will take minimum 2 incident ray from each point to form the image. So let's mark here 2 light rays are incidenting on the plane mirror, this one and this one, at an angle of 90 degree. Now what is the rule? If incident ray strike the plane mirror at an angle of 90 degree, it will retrace its path. Definitely. So it will retrace its path means reflected light rays will be on the same path. Okay. Why? Because we know that it's a plane mirror. It's a plane mirror. So in plane mirror, if a light ray is coming at an angle of 90 degree, then what is the angle I? Angle I is 0 degree. That means angle between normal and incident ray is 0 degree. And we know that angle I is equal to angle R. So definitely here angle R will be also 0 degree. That means angle R will be 0 degree means reflected ray is going like this on its original path, right? So here 2 incident rays are there from A point and from B point, and they will reflect back like this. Now we require 2 more incident rays. So this one from point A and this one from point B. Definitely it will also reflect. So it is reflecting here and it is reflecting here. How? Because you will draw the normal, you will mark angle I, angle R, right? I dash, R dash. You will find angle I, angle of incidence should be equal to the angle R. That means angle of reflection. Definitely. Now what we will do? We will find that from point A, 2 reflected rays are there, 1 and 2. And we know that these 2 reflected rays cannot meet in actual. Okay. But similarly to the point object, we extended the reflected light rays behind the mirror. So here also we will extend reflected light rays behind the mirror, and we will find that yes, reflected light rays are appear to meet at a point, right? So let's extend these reflected light rays behind the mirror. you will find that these reflected rays are appear to meet. Just join these 2 points and you will find the image of an extended object. Properties are same. Image will be virtual and erect. Why? Because light rays, reflected light rays are not meeting actually. They are appear to meet. Why it's lateral inversion? Because left-right inversion, left side will appear right side of the image and right side of object will appear left side of image. And the image will be exactly in the same size as the object, and distance of image from the plane mirror will be exactly equal to the distance of object from the plane mirror. Alright students, so this we have discussed, how to form image in the plane mirror. Moving further, angle of deviation, that is denoted with del. Okay, so what is angle of deviation in the plane mirror, students? This is the question. We know that wherever incident ray strike the plane mirror, it get reflected. But if we will not consider any reflection, then what will happen? Incident ray will go in a straight line. Okay. So incident ray will go in straight line, but it is getting reflected because of the plane mirror. So the angle through which the incident ray of light is deviated from its actual path, from its original path when it is reflected from a mirror. Let's take, this is the plane mirror, incident ray is this and it is getting reflected, okay. But we have to find the actual direction. So we know that this is the incident ray, and if we will consider the property of light that light ray always travels in the straight line, so we will find that the actual direction of this incident ray is this straight line. So we will mark here, this is normal, this is angle I, this is angle R. We can mark here, this is angle I and this is angle R. Angle I should be equal to angle R. That is why if angle I is X, definitely angle R will be also X, right? Now students, we know that what is the actual path, actual direction. This is the straight line. So this is the actual direction. But incident ray will not go in actual direction, it will reflect. That means the angle at which the incident ray has deviated from its actual direction, that angle is known as angle of deviation. This is angle of deviation, students, this one, that is denoted with del. Now how you will find this del? So we know that what is the angle at this line, this angle at this straight line, it's 180 degree. Sum of all the angles at this line will be 180 degree. Now what are the angles? X, X and del, okay. That means I can say angle I is equal to angle R, that is X, and angle I plus angle R plus angle of deviation is equal to 180 degree, right. Now angle I is X plus angle R is X plus del we have to find is equal to 180 degree. X plus X, 2X, 2X will go that side, it will become minus 2X. So del will be 180 degree minus 2X. Okay. So what is the formula to find out the angle of deviation? It's 180 degree minus 2X. Let's say the angle of incidence is 30 degree. Let's take the example that angle of incidence is 30 degree. So that means X is 30 degree, right? Angle I is 30 degree. Now we have to find the angle of deviation, students. So how we will find angle of deviation? We know the formula, del is equal to 180 degree minus 2X. So here del will be 180 degree minus 2 into X is what? X is 30 degree. So we will put here 30 degree. So del will be 180 degree minus 2 into 30, it's 60. 180 degree minus 60 degree, it's 120 degree. That means what is the angle of deviation? It's 120 degree, students. That is how we can find the angle of deviation. Moving further. Now we will discuss, students, multiple reflection of light. If there are more than one mirror, let's suppose 2 mirrors, 3 mirrors, more than one mirror, what will happen? Let's suppose one light ray is incident on the first mirror. Then from first mirror it will get reflected. Now that reflected ray from first mirror is striking on the second mirror. So for the second mirror, the reflected light ray from first mirror will become incident ray. And again, the reflected light ray from first mirror, when striking the mirror second, it will reflect again. That means reflected light ray is getting reflected again. That is called multiple reflection of light, students. So when the reflected light ray is reflected again, this process is called multiple reflection of light. Just you can observe here. Okay. Moving further, we have the example, hairdresser shop. Just observe. For looking our backside, we use two mirrors, right? One mirror is backside and one mirror is in front of you. Okay. What will happen? The light ray from our backside will strike on the backside mirror. Then it will reflect and it will come to the front mirror. And again, from front mirror, it will get reflect again. Okay. And it will enter in our eye. So that's why we can observe our backside in our front mirror. That means the reflected light ray from backside mirror is getting reflected again from the front side mirror. That is called multiple reflection. Okay, students, now we will discuss about the mirrors. Let's take two mirrors are placed perpendicular to each other. Okay, two mirrors are there, mirror 1 and mirror 2. Just observe here, mirror 1 and mirror 2. And what is the angle between the mirror 1 and mirror 2? It's 90 degree, right? Now we have to find how many images will be formed due to the multiple reflection. So topic is multiple reflection of light, and here the theta is 90 degree. Theta means angle between the mirror. So it's theta, that is 90 degree. Now the number of images will be formed will be 3. Okay, how? Let's look at the diagram. Just observe, this is the point object. We know that we require minimum 2 incident rays. So 2 incident rays are incoming light rays for mirror 1. 2 incident ray on mirror 1. This is mirror 1 and these 2 are the incident ray. Definitely it will get reflect. So from this it will get reflect and from this point it will get reflect. Now by extending reflected light rays, we will find these reflected light rays are appear to meet at this point. So at this point first image will form, this is I1. Okay. Let's observe the distance. If the object is at a distance x, then image is also at a distance x from the plane mirror, that is mirror 1. Similarly, we can say these incident rays are reflected and these reflected rays are striking on the mirror 2. Now, these reflected rays from mirror 1 will be incident ray for mirror 2. Okay, that means again these reflected rays will get reflect. Okay, so from this point and this point again the reflected rays are reflecting. Now if we will extend these reflected rays behind the mirror, we will find these reflected rays are also appear to meet at this position, at this point. That means this is our second image. Okay, this is our second image, I2. Now I3. So how I3 will form? Just like I1. Okay, we don't require any ray diagram for I3 because we know that whenever the point object is placed in front of a plane mirror, every time at a same distance, that means if it is placed at a x distance, then image will be formed at x distance from the mirror. Let's take the object is at a distance y from the mirror 2. Definitely behind the mirror, that means in plane mirror second, one image will be formed at a y distance from the mirror 2, that is I3. That means how many images are forming? 3 images are forming, I1, I2 and I3. Let's take one more example. If 2 plane mirrors are parallel to each other. Okay, 2 plane mirrors are placed parallel to each other, just like here. Here 2 mirrors are placed parallel to each other. Just observe how many images are forming. There is a candle, okay, which is object. Just observe how many images are forming. Infinite, okay. So how it is forming? Let's observe here. So when 2 plane mirrors are parallel to each other, they form infinite number of images of an object placed between them. Let's see the image formation, or I can say ray diagram. Let's take, this is the point object which is placed between the 2 plane mirrors. These are 2 plane mirrors and we have placed one point object. Now we know that incident ray will strike on the mirror. So these 2 incident rays are striking on the mirror and they are getting reflected. So So by extending these reflected light rays behind the mirror, we will find our image 1. Now these reflected rays are striking on the mirror second. So again it will reflect. So by extending these reflected rays, we will find our image I1 dash. Let's take here. So again these reflected rays will strike on the mirror 1. Again they will reflect. So by extending these reflected rays, we will find third image I1 double dash. Let's take 2 incident ray on mirror 2. So again they will reflect, and by extending reflected rays behind the mirror, we will find I2 image. Now this incident ray for mirror first, but it is reflected ray for mirror 2. Let's take, this is mirror 2, this is mirror 1. So from mirror 2, this is reflected ray, but this will become incident ray for mirror 1. Definitely it will reflect again. So by reflecting these light rays and by extending these light rays behind the mirror, we will find I2 dash image. Again this will reflect, and by extending these reflected rays behind the mirror, we will find one more image, that is I2 dash. That means this process will continue. Okay, this process will continue and we will find infinite number of images, because you know that there will be so many incident ray and so many reflected rays, and reflected rays will reflect again and again. So by using this process, we can find infinite number of images in the plane mirror when 2 plane mirrors are placed parallel to each other. So students, what we have understood in this section, in this class, we have understood about the plane mirror, image formation by plane mirror, alright, and multiple reflection of plane mirror when plane mirrors are placed at an angle that is 90 degree and plane mirrors are placed parallel to each other, and we have discussed about the angle of deviation.